Welcome back, everybody. This is going to be part 1 of 2 in my lecture series on challenging inequalities. In this video, we're going to take a look at what happens when polynomials show up in inequalities. Let's get started. I think with this case, there's no better way to get started than with an example. Find all x that make this inequality true. X squared minus 5x plus 4 is greater than 0. For problems like these, we need to use what's called a sign chart. This is essentially going to be a number line with some extra information. If you think about the shape of these graphs, remember they kind of look like big wiggles? Well, every time it crosses or touches the x-axis, the sign of the graph may change there, right? It may bounce off and stay positive, or cross through and become negative, or something like that. But at the zeros of the polynomial, we have the potential for a change in sign. So let's start by finding those potential places where our sign can change. First of all, let's treat this as though it were an equality. Right, so let's find when x squared minus 5x plus 4 is equal to 0. I can factor this into x minus 4 and x minus 5, and x minus 1 equal to 0. So this is equal to 0 when x is 4 or 1. And now I want to populate my sign chart with those values. The next thing to do here is to check a point in each of these regions, right? Because since these are the only places where it'll change sign, all of the points in between 1 and 4, to the left of 1 and to the right of 4, will have the same sign as one another. So let's try 0, for example. We'll pick 0, 2, and 5 as our test points. When it's 0, I get 0. Oops, I get a black screen. There we go. When it's 0, I get 0 minus 0 plus 4 is greater than 0, or 4 is greater than 0. Here, it works. My inequality holds in this region. Now let's check the middle. Let's try 2. I would get 4 minus 10 plus 4 greater than 0, or negative 2 is greater than 0. This, obviously, is not true. So, it does not work in the middle region. Last but not least, on the right side, when I try 5, I'll get 25 minus 25 plus 4 is greater than 0, or 4 is greater than 0. Here it works. So in the right-hand region, it works. This tells me altogether that negative infinity to 1 together with 4 to infinity are the sets of x values that work. And you'll notice I'm not including 1 and 4 in this problem because for 1 and 4, we already said that's when the left-hand side equals 0, and 0 is not greater than 0. So we'll include these endpoints when I have an or equal to in the inequality. Let's try another one. Why don't you pause the video here to see if you can try that orange example on your own. Here's the answer that I found. I got negative infinity to negative 4, including this time, since I've got an or equal to in my inequality, and 1 to infinity, including 1. Feel free to pause the video here to check my work. Otherwise, let's try a slightly different problem. Notice here that I've got terms on both sides of the inequality. Well, the simplest way to tackle this problem would be to just move everything to one side. Because this is the same inequality as x squared plus 9 minus 6x is less than 0. And now this looks like a problem that we've already tried. go ahead and pause the video here to see if you can finish it off. For this problem, it actually turns out that there are no solutions. Remember, it can only change sign on either side of 3, so if I check a point on both sides, I get that it doesn't work in either case. Let's try one more. Go ahead and pause the video here to see if you can tackle this problem on your own. I found that the solution set is 1 to infinity, excluding the 1. Notice that the solutions, or when it's equal to 0, are when x is 1 or plus or minus 3i. But I only need to consider my real solutions. So I'm just going to look at 1 on my sign chart. I tested 0 and 2. 0 gave me that the inequality doesn't work, so it doesn't work to the left of 1, but it does work to the right of 1. In this video, we saw how to tackle inequalities involving polynomials. In the next one, we're going to look at how to tackle inequalities involving rationals. Catch y'all on the next one.